Hi, this is Mrs. Slater. The quote of the day from Michael Scott: do I want to be feared or loved? That's a good question. I want both. I want people to be afraid of how much they love me. Okay, so we're going to start on 11.3, but a little weird just because we're going to go to the bottom left-hand corner and have a few things to discuss. Should be a little review, but in case you have forgotten, I just want to talk about conjugates. That is when you have A plus BI, and then the conjugate of that is A minus BI. So the inside sign is going to change. Same thing with radicals. If you had A plus the radical B, then its conjugate is going to be A minus root B. So notice the sign is the only thing that changes. Okay? And the one thing you need to know is that we really didn't emphasize way long ago when we talked about conjugates is the fact that they always are going to come in pairs, which is going to be helpful for this lesson. So some examples. If we already know that 1 minus I is a complex root, we know automatically that 1 plus I is going to be another one. Maybe another example could be if I know one of them's 3i, then another one has to be a negative 3i. So those are going to come in pairs. Okay, and then same for irrational roots, which in this case you're always going to see the radical sign. An example of that is 1 plus the square root of 2. And then another root would have to be 1 minus square root of 2. All right, so now I want to go back to the first part, top left-hand corner, and I want to make you a believer. So in this first one, if I'm going to find the roots by factoring, we know that the factors of x to the fourth are x squared and x squared. And then this is a difference of two squares, so one's going to be plus and one's going to be minus. And if I went ahead and used the zero product property, x squared equals 9, so x is going to equal plus or minus 3. Same thing on this one. If I use the zero product property, I get x squared equals negative 9. And if I take the square root of both sides, notice I have a 9, a negative inside of there, so it's going to be plus or minus 3i. So this is referring to complex roots always occur in pairs. So that will always happen. You're going to have plus or minus and then the 3i. So just to emphasize, imaginary roots come in pairs. Well, are in pairs. Okay, so on the, I'm going to go ahead and skip that one and go to number 3, because it did not have irrational or imaginary numbers in it. This one, though, on the other hand, if we're going to factor this, it's going to be x squared and x squared, and factors of 2 that are going to give us 3 are negative 2 and a negative 1. And if I take both of those and use the zero product property, I get x squared equals 1, so x is going to equal plus or minus 1. Okay? Integers do not have to come in pairs. It just for these two examples, it happens to be that way. But this, on the other hand, has to always come in pairs. Zero product property, take the square root of both sides, plus or minus radical 2. That will always happen. So irrational roots will be in pairs. So those are just examples of the two of them. I am going to skip 2, 4, and 5 because I already got my two things that I wanted to discuss. All right, so let's go ahead and go to number 6, I believe. And there it is. Okay, maybe not. All right, so I found it. And here we go. Suppose a polynomial of a degree 6 with real coefficients has the given roots. So here already they're giving us 4. 1, 2, 3, 4. And if we know that complex numbers come in pairs, we know the other two roots. This one is going to have 5 minus I, and the next one is going to be a positive 2i. So we've changed the sign just in that one location. So you have the other two roots. Go ahead and push pause and see if you can figure out the next ones. Okay, so we have 8, 6. That is one root. Be careful there. So that's going to be a negative 3 plus 2i. You do not change the sign the first time. Stay away from that. And then the other one is a negative 4i. And then the last one, push pause and see if you can get this one. Okay, we have 2 and negative 3, so we don't have to do anything to that. But here is a root that is imaginary, and here's a root that's a radical. So the other two roots are going to be 3 minus 2i and 1 minus the square root of 3. Okay, so let's go ahead and go on to the next screen. Okay, so I'm going to go ahead and start a list. They give us one root, and we just learned that imaginary roots are going to be in pairs. So I'm going to start a little list. I know, well, I know, maybe you don't know, but there is going to be 4 roots that are going to happen. Why do I know that? Is because the degree is 4. So keep that in mind when we do the rest of the examples. So we know we have 4 answers. How do we find the other roots, which is what the mission is that we have to accomplish? Okay, so if we know those are the roots, we also know that these, if you set them equal to 0, so you have negative I and x equals I, x plus I equals 0, and x minus I equals 0, what we have just found are called the factors. And anytime you have the factors, you can multiply those together and find the polynomial. So we have x squared minus ix plus ix minus I squared. And we had a lot of practice on this in lesson 11.1 with the imaginary numbers. These are going to cancel, so that's nice. And then we have x squared minus a negative 1, which we know is x squared plus 1. All right, so we did all of that so we could figure out what the other roots are. So we have x squared plus 1, and anytime you have x squared plus 1, we're going to have to use long division. So x to the 4th minus 5x cubed plus 7x squared minus 5x we're going to put inside of the division sign. Okay, so let's go ahead and start. This is a good time to push pause if you'd like to try long division on your own. It's good practice. So x squared times x squared is going to give you x to the 4th. So we're going to multiply that through, keeping all the same exponents in line. And then we're going to go ahead and subtract. So minus, and plus 0, so that'd be a negative 5x cubed plus 6x squared. And we're going to bring the negative 5 down. Okay, so then x squared goes into negative 5x cubed, negative 5x times. And if I multiply that through, I get negative 5x to the 3rd minus 5x. And next thing, subtract. So subtracting is going to make both of those positive, canceling them out, leaving me with 6x squared. Those cancel out, leaving me with plus 6. And then my last move is to go x squared times what? Going to give me 6x squared. And that's going to be 6. So we have 6x squared plus 6. And then after you subtract them both, they end up canceling and giving you no remainder. So that's good. And we'll take that answer and use it down here. So we got x squared minus 5x plus 6. Now that is not what the question is saying. They're asking what are the other roots. So what do we have to do to this to make it happen? We're going to factor. And if I factor this, then use zero product property, x equals 3 and 2. And I can answer the question. What are the other roots? They're going to be 3 and 2. All right, so I know that's a long process, but once you get the hang of it, you're going to do great. All right, let's go ahead and move on to number 8. This one, you can see the degree is 3. So that means there's going to be 3 answers. I'm going to go ahead and get this erased. And not sure where that comes from. Oh, yes, I think I do. That goes down here. Okay, so what we're going to use here is a little system. We'll put our 3 blanks. Negative 3 has got to be one of them. It's not imaginary and it's not rational, so I can't do the pair. But what I can do is place the negative 3 inside of the synthetic division form, and we have 1, negative 7, and 15. Push pause and go ahead and solve that. We got 1, negative 3, negative 4, 12, 5, negative 15. Okay, and then we can take the answer, very similar to 11.1, 11.2's lesson. And then we have minus 1 and minus 5, and it looks like I need that to be a plus 1. So with zero product property, I can get negative 1 and 5 for my other roots. So all of those are the roots to this polynomial, that polynomial. All right, let's finish up number 9. And then we have this square root of 7. Let's make our little list off to the side again. Square root of 7 means it comes in pairs. All radicals come in pairs. And then we have 2 left over. The reason I know that is because the degree is 4. All right, so with the radicals, setting them equal to 0 is going to help you out. So x plus radical 7 equals 0, and x plus radical 7 equals 0. So you can already see I made a mistake on that first one. When I subtracted, I should have got x is x minus radical 7. And now that these are factors, I can multiply them together. Okay, and what do I get here? Whoa. So I'm going to multiply those together. First, outside, inside, last. So I'm left with x squared minus 7 for one of the factors. Or not completely factored, but that's one of the factors. So we're back to the long division because it has a degree of 3. X to the 4th plus 4x cubed plus 2x squared minus 28x plus 0. There's a missing term right there. Okay, now again, push pause, see if you can practice long division. The better, more practice, the better you're going to get at it. X squared goes to the x squared times. And then x to the 4th minus 7x squared is going to go here. And then after subtracting, it's going to look like this, where you have 4x to the 3rd plus 9x squared, and then this is going to be brought down negative 28x. Okay, so then the next move you're going to make is x squared times what is going to give me 4x cubed. So that would be 4x, and when you multiply that through, it's 4x cubed minus 28x. And then after you change the signs, we want to subtract them. Only 9x squared is left. And if we bring down that 0, not much is going to happen there, but x squared times 9 is going to give you 9x squared. So we have 9x squared, and then minus 63. So when we add those together, what do we get? Minus and then plus. So we get a remainder of 63. Okay, so I'm sure you already found my mistake, so I'm going to go all the way back up to here where I put plus 0 for some reason. Well, I can get rid of the plus as well. I'm going to put in my negative 63, and now that I bring that down, that is fabulous news because now I have a remainder of 0, which is what I was supposed to get to begin with. Okay, so then what we have left is x squared plus 4x plus 9. And if we can factor it like we did in problem number 7, that would be great. But if it doesn't factor, we get to do some more math, which is the quadratic formula. X equals negative 4 plus or minus square root of b squared, so that's b squared minus 4ac all over 2a. All right, and after simplifying it, we get 16 minus 36 all over 2, and then negative 4 plus negative 20 all over 2. And this is going to prove once again that imaginary numbers are going to come in pairs. Negative 4 plus or minus 2I root 5. Check your work on that one. And then this right here in that little triangle, we're going to reduce. We have to do it to all of them. Our 2 goes into all of them, so it looks something like that. So we have just found the other 2 roots, and we can put them in our original problem. So we have 2 plus, now I forgot what it was, I root 5 and 2 minus I root 5. Okay, so to finish up, we will look at multiplicity. And in multiplicity, when p of x have factors that occur multiple times, we'll finish the rest tomorrow.